That is a perfect time to have something in my eye. Just my plan. That is awesome. So it's a Thursday night, and we are back with the design team from the Lift and Shift Foundation. I think that's the intro I'm going to start going with, because this isn't really just me at this point. But I'm the founder of the Lift and Shift Foundation, and I'm also a member of the design team. So we have this design team, and the design team's purpose is to kind of help us build things as far as our nonprofit program. Say that 5 times real fast. Our nonprofit program, and some of the things that we want to do as we give back to our community. So we work on some of the Battle of the Bots program, which is a really cool, really fun program, and I encourage everyone to come back on Saturday and check it out. We'll be doing another build day on Saturday. We've got a bag of parts. I just got this bag of parts in. These are ultrasonic sensors. There's a small bag of them here that just came in. We're gonna build our second big robot, the big Ranger tank we're gonna build, and we're gonna finalize some of the arena that we've been redesigning over since Memorial Day, basically. Just before Memorial Day. But that's a program that the design team is pitching in with, and developing with us. And I'm just checking to make sure there's sound for anybody who's listening in on Twitch. There is. So it says there is. If there isn't, chat at me, because I'm not the sharpest tool in the shed all the time. But anyway, back to our design team. Our design team is really here to work with the Battle of the Bots program overall, and I have some water. It's plain soda water with just a bit of cranberry juice in it, but it's very hot in my apartment today, and that's the last distraction for the evening. Excuse me. So the Battle of the Bots program, as I've been trying to explain, it is very cool. And come back on Saturday to watch us do stuff with robots, and maybe we'll start battling them on Saturday. But I assume the rest of the Saturday will involve testing ultrasonic sensors, and we have a new mat. I went and laser printed some dark color ovals to see if the laser printer picks up the changes in the line sensor, the infrared light stuff. So but I'll talk about that Saturday. That's kind of like nerdy physics engineering stuff. Tonight is all about our design team and some of the projects we've been doing with other veterans. We've been making a cookie cutter. We are designing our own prizes and trophies for Battle of the Bots. So Battle of the Bots is actually a program that happens here live in New York City, and we wanna include the design team in the process. Oh, I am frozen in Teams. No. That's disappointing to me. Okay, so and our design team, we're all connected on Teams right now, a Teams view, and it sounds like I am frozen on Teams, but not on my view. So I don't understand. Like, I can still see me waving, and I can still see everything else. It's very awkward. And we've had this problem a couple times with me sharing streams and views and feeds and things. Sometimes my desktop does not like this idea. Yeah, maybe on your end. I don't know. It seems like this happens on Teams more than anything else. We may go back to Zoom for some of this stuff, because Teams is a little more awkward. But we're not a partner. We're not a Twitch partner, so I can't share our nonprofit's feed with our team. That's a feature for partner accounts. And while we're building our partner account, I share this stream by inviting our team to join me on a live sharing, another meeting platform. Usually that is Zoom or Google Meet. Today it's been Teams for a few weeks while we tried Teams out. Teams, it seems, is freezing more, and yeah, that's a bit of a problem for me. But our design team is here. It's not just me. It's not. I don't run the show. I'm just here as kind of like the face to show off what this team has been doing, and you can kind of see it up there. There's some cookie cutters we've been working on. There are these prizes we've started designing for Battle of the Bots. So we want to give these things away. We want to 3D print them and give them away to families, to veterans, to everybody who participates with us. I'm so psyched about this. I love seeing, we have a Slack workspace. This is how we operate, and we're literally all over the country as a team. And in the Slack workspace, somebody will drop a link and say, "Hey, I just designed this," or "Hey, check this out," or look at this thing. And I love seeing this stuff. This is why I will not tell people I run the design team. I am a member of the design team. It just so happens I run the nonprofit, so I can make things happen if the design team needs parts or something else. But for the most part, I'm there because I'm kind of a nerd like everybody else, and it's my release. It's my way to kind of like relax after a crazy day. It's been nonstop roller coaster over here today, where my inbox has just been bananas, and running a nonprofit, running an organization. I still work part-time in a research lab. A lot of those things are the daily grind for so many of us, and being able to dive into a hobby, to be able to make things and to develop things and build things is something that provides me a bit of a relief and a bit of a break from like the daily grind, and I appreciate it. This is why I will participate with the design team as long as humanly possible. I do a couple other things. I run marathons. Those kind of things to keep me busy and keep me stress free is part of my self-care plan, and I hope everybody else has the same plan. But I'm gonna stop talking about me and start talking more about these projects now. If you're curious about more of this stuff, we have a website, the Lift and Shift Foundation. We Lift and Shift is pretty much the name anywhere, and you can go and you can dig around the website. There's more resources coming for stress, for anxiety, for PTSD, for if you don't know what hobbies to get into, that kind of stuff. There's a lot to do to take care of yourself, and that could be making cookie cutters. It could be a variety of things. It could be photography. It could be gardening. You could build a rocket ship. There's all kinds of things. But that's just my take on what the design team gives to me and how I enjoy this process. So with that being said, I want to share a little bit about this cookie cutter. We've been making cookie cutters for a veteran who asked us, maybe challenged us, said, can you do that? Can you make cookie cutters? And yeah. So basically, the bottom line is, if you let me here chat a bit, let's switch views. So this is cookie cutters. Excuse me, and this is what we've been working on for a little bit. Let me change my view on this end and say, let's see, right here. There we go. Cool. I can't see my chat window, so if anybody's chatting at me, there we go. I can see it all now. Cool. So these are the cookie cutters we started with a couple weeks ago. We started with this yellow model right here as our base shape, and I did some Inkscape magic and brought this into Tinkercad as a shape from a picture. If you missed that stream, it might still be up. If not, I'm not going to dig too much into that tonight, and I don't think we're gonna stream for the full 2 hours. But I'm gonna chat a little bit about this and about some of the problems I've had with it. The first one was some of these designs are very bulky and very big. We designed these two cookie cutters right here, these two tan ones, first as a team, and the intention was to imprint the shapes in the dough. What we wanted to do was we wanted the star and some of the chevrons from this E8 rank, we wanted them literally imprinted in the dough as this cookie cutter edge right here, like bit into the dough and sliced the outer shape of the cookie. So we tried two different options, and check it out. We come back to my view right here. I have those right here. I printed them. They are right here, and you can kind of see them. Here they are. They turned out really well. They turned out pretty good for 3D prints. They're very, very good lines and shapes and things, and even this one. So what I did on here was I added this. It's very intricate designs, and I was afraid that they would snap off for the user after time. So I put this bar down the middle, and I did not like the bar down the middle. After we printed it seemed restrictive. So I went about redesigning these after we spent like 2 hours as a team, figuring out this whole let's turn a picture into a 3D object. So I talked to our veteran who gave us this challenge, and I'm not a cook. I don't do like pastry chef stuff. So what I did not realize is there's this thing called fondant. I don't. Is it French? I don't know. But apparently you use a cookie cutter to cut like layers of icing, and now I'm excited about this. I'm gonna try it myself. But that means there's kind of, this is restrictive. So we went about redesigning these prints, and the first redesign we did, if we come back to our big screen here, and if I click on this, the first redesign we did was we separated the inside and the outside, and we made this shell, and we made this cookie cutter that actually cuts the shape of an E8 rank for the Air Force. And this works really well. This printed really well. It printed right here. Check it out. Here's the cookie cutter print. It printed well. I have not tried it yet. I might try it tomorrow. I've got some dough, and it's not cookie dough. It's biscuits. It's that biscuit dough. But I might try it. I might mash up a biscuit and see how well this cuts. I'm really dying to try it. And I passed cookie dough in the grocery store as I got some other props, and I did not grab the cookie dough because I was not going to drag this into my little tiny kitchen. But here it is. Here, this is it right here. And check it out. We also, where is it? Oh, we tried this because I'm just curious about this shape right here. So this is the shape of the chevrons on the top, and the rockers on the bottom, and the star, just like the rank of E8. This is almost a mirror image of the image, the picture of an E8 rank, and this works really well. But I think the user will have trouble pressing this in and out. So we want a step further. I went into Photoshop after last week's stream, and I created this shape right here. I created a trace of the image and the picture, and I started using the trace of that, basically this black shape that you see here, right here, and that worked out. That turned out so good. Look at it. It turned out great, and I started printing it, and I realized that the dough is going to get stuck in these little grooves, or the fondant, the icing, is going to get stuck in those little grooves, and you're not going to be able to poke it out. So I created a second option, and you can see it right here. It's got these holes in it on the underneath, so you can poke out the icing from underneath with like a stick or a straw or I don't know, a fork, something else. And my goal was to make this work so that you could poke the dough or the icing out of the back. And I set out to print all three of these, and I just want to update you about the printing process, because it's been a very big challenge for me. You can see I have one model. I printed one that printed successfully. If we come back here, so I got this one printed out successfully, and you can see right here on the screen, it turned out really, 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 really well, except if you see right here in the middle, there's this circle in the star, and it looks like it's not gonna cut well So I removed the circle from the star in the shape. You can kind of see it up there. I'll go back to that in a second. So I removed the circle from the middle of this. The other problem I had with this particular print was it's very thin. I'm and like I said, without the holes in the bottom in the bottom, you won't be able to remove the stuff without like kind of like mangling it up. You'll mangle the icing up, and it won't really work so well. So my edits, as you can kind of see there on the screen, if we go back to my options here, this pink version here, which is the same one that I was just holding up, I raised it taller. I made it very, very tall, so there's room for the fondant, and it doesn't get stuck and it doesn't get jammed. And I did the same with the blue one. I raised it up while I added those holes underneath, and well, I'm just going to show you right now what happened. Here's a picture of the first print. So that is a picture of the print with the holes. And I just got to say, I've done this twice now with the holes, and it just keeps falling apart on me. And it is not a flaw with the printer or my settings or anything else, because I've printed dozens of other objects with this. So I'm going to show you basically what I think is happening here. So what I think is happening here is we've got these grooves right here, the holes that I want to poke out the fondant or the dough or whatever is inside of it, and I want to poke them out from the back. But what I've done is I've created like a space where there is no surface to connect the rockers and the chevrons and things. Those like ridges that stick up, they're not connecting all the way around, and as the nozzle is moving back and forth, it's pulling this stuff and it's pulling it away from basically nothing that's holding it together. So I think adding these grooves is the problem, and right now I have proof. It's proof is printing right now. I have this print back on the printer on a taller version, so the grooves keep failing, and I think this one is going to print accurately again, which will tell me that this has failed twice with the grooves, and this will print twice without the grooves. So if that turns out to be the case, then we'll be able to say for sure that I'm listening to the printer. It's literally like 3 feet from me, and I heard some crackling, like it was gonna fail. The print, like it was all pulling apart. So I'll if I stop and give a break and show a video, I'll come back with the print and show everyone what happened live right here. That's funny, but seriously, I printed this last week, before the weekend, and since the weekend, my apartment is, I don't know, 5 degrees warmer. It got very hot here all of a sudden in New York City. So there are fans on and things, and sometimes that the temperature and the air movement around these prints will change some of the settings. And I had that happen last summer, where all of a sudden I had all kinds of prints failing. So that's why I'm printing a second version of this to find out what's wrong. Plus, I don't want that circle in the middle, because I feel like that's not a good feature to have. So we're running a test on the printer right now, and hopefully it finishes printing and it works out well. But we'll keep working on this while we're doing it, because the rest of this has actually turned out great. And let me scroll through some of this. Yeah, right there. So you can check this out. So here's the cookie cutter that I just showed you. Let's take a big look. You can kind of see this circle. That's not going to cut very well. That's not going to cut very, very smooth and very even with the points. It's going to be a mess for somebody to have to deal with. But the cookie cutter is great, and it's tall, and you'll be able to cut a bunch of stuff with it, and it should work out well. I dig it. So that's what we have now, and that's what it looks like now. And that is my print with this crazy this crazy grooves that don't seem to hold anything together. So let's check out what else we got here in the prints. Okay, yes. All right, we're gonna move into. Yeah. So that's a good point. I should before we move into the light bulbs, these slip inside of each other. So they slip inside of each other, and this was something I saw in some other. Oh, my print is failing. So I can hear my print failing right now. So I may take a break in a minute and play a video while I pull it off the printer and come and show you what it looks like when it fails again. It's special. So this tells me that the problem may be that my apartment is like 5 degrees warmer today, which is weird, and I'm not quite sure why, but I'll have to go check the thermostat on the AC. But it feels warmer, and it feels like there's no air moving around. But it is probably 10 degrees warmer in New York City today, or since the weekend, since the holiday. But yeah, so these slip inside of each other. Ooh, let me bring that back. They slip inside of each other like this, so that you can cut your cookie, and then you can press, if you want to press stuff on it, you can press this on it, or you can press this on it and leave the imprint in it. So these are meant to be like a set, and we're gonna mail these off. And basically, it does the same thing as this, except this inside part is removable now. So that's basically the difference between the two, is that if I hold these up together, we basically created a set that works much better together than this. This is, you can do this, and you can imprint your cookies, and you just get this cookie shape with kind of like these bulges on it. This one you can use this in much the same way, where you can take this part out and just use it to cut the fondant, the icing part. So this works much better. And yeah, that is a good point from our team. And thank you. I assume you ditched the Teams meeting, and you're watching over on Twitch now, and that's cool. That's fine with me. I'm curious to see what's happening with this printer. It's a mess. I'm gonna let it print for another minute before I take a break. Actually, now we're kind of done chatting about that, so I might just take a quick 2-minute video break and go pull it off the printer and come back, and then show it off and switch gears and talk about our light bulb bottle opener, can opener type Battle of the Bots prize, because I'm psyched to do this. This is kind of the meat and potatoes of tonight. So let me do that. Let me switch views here, and we will. I'll play a quick video while I hop on the other side of this desk and change stuff. Ooh, you can kind of see my Battle of the Bots logo right there. Okay, fixed it. Let's see what I'm gonna play. I'm gonna play this tiny little intermission video from our sponsor Clever, to tell people how to use Clever if you've never used it. It's a prescription benefit plan for anybody. It's free. Nobody needs to do anything to join it. You can go to our website. You can find it there in the resources. You can look up your prescriptions. If they save you money, use it. That's what it's there for. Lots of veterans have issues with tracking down medications, and the VA is usually pretty good if you're in the system, but sometimes you can get it cheaper elsewhere. So it's there. I'm going to play the quick video, and I might beat it done, but I'll be right back. Okay, that's enough for the video. Thank you. Cool. So it's a good video. It's okay. I made it, so it's not great, but here is my print. You can see what should be the little lines going back and forth. These are all the little strings of filament that have come out of the printer, and they're not fastening to the bottom plate. So if we take a peek at, let's see, let's grab this right here. You can see there's a bottom plate, right? So there's the smooth plate on the bottom that this is attached to the glass. This is attached to the glass. But then you start to see all of the shapes that are drawn on, and they're not sticking to the plate here. So you can see it. If I pull this away, you're going to see that it's perfectly smooth. All of the very thin lines are so thin that they are they're not attaching very well to the rest of this. So as I pull the rat's nest away, ready, you can see only some of it, like right here, is actually attached. And I can pick it off, and I can pick it off right there, but only like a very top part of it and a very bottom part of it are actually attached to this plate. The rest of it is smooth and flat. And to me, that's now telling me that I have an adhesion issue. It may be that the lines that are being drawn on here are too thin. So let's take a peek at that very quickly. I'm going to measure them, and we're going to check this out. We're gonna do a little problem solving on this print. But for the record, the rest of this looks so smooth. That's the top after I peeled this off. This part of the print turned out great. It really did. It turned out very good. There's no curling on the outside of the print. It doesn't look like a potato chip. It's not wrapped up. Everything worked well on this print, except for the fact that the little thin walls, the little thin lines, did not stick to the plate. So let's take a peek at this and see. You can see they're very thin. We're going to go back to the big screen right here. So let's check this thing out right here. Let's zoom in on that right there, and you can see that they're very thin, especially compared to, they're even thinner than the cookie cutter part, and that may be the problem right there. So you can see that the cookie cutter blade, as I'm calling it, is right there. And you can see the difference between the two of them. Oh, you can kind of see my mouse right there. The difference between the two of them is very thin. I'm gonna measure that right now, because I think that might actually be the problem for us. And if that's the case, maybe we can alter that in Tinkercad. We can take a try. But we're gonna come back to my big screen here. I'm gonna break out the digital caliper for a second. Digital caliper right here. And we're gonna measure the blade. This blade right here, this blade part, we're going to measure that. And of course I'm doing this backwards, so you can't see it. The blade has a thickness, if I do this, 1.3 millimeters. So this part of the blade right here is 1.3 millimeters thick. And these look thinner on the screen, right? Like up there on the screen, they even looked a lot thinner. That is, whew, 1 millimeter thick. So it is only a millimeter. It's well, it's a lot smaller, like I don't know, 25-30% smaller, something like that. I'm not doing math tonight. Math is not what we do on Thursday night Twitches. Let me turn off my digital caliper here. So these lines are significantly thinner, and that may be why there's a problem with them sticking to here, because it's a lot of material, and it's only got 1 millimeter of worth of contact with the plate. So I probably got lucky with this one, to be honest. That may be what happened. It might not have anything to do with the heat in my apartment. Yeah, it probably just got lucky because you can see this is actually very, very flimsy right here, even at 1.3 millimeters. So the backing for this one is a lot. This is a lot thicker. I think it's 3 millimeters thick. So that kind of keeps it together. That's terrible. It's 2 millimeters thick. So that kind of keeps it together, but it doesn't keep the little fin type material, the little walls, the little cutters. It doesn't keep them on attached to the flat plate. So it's possible we change that in Tinkercad. I can do that. We might do that tonight. We might do that right now and try. I will try this again over the weekend. This print. So our other print, which we were going to get to in a minute. I've got props and everything all set up. I was super excited to contribute as a design team member to this project, but I want to finish the cookie cutter. So let's do this real quick. Let's dive into the cookie cutter. I'm going to switch screens right here. We're gonna go into the cookie cutter. Let's make this big. Let's duplicate this very quickly and drag it up here and get our own little view of it right now. So let's take this apart. Awesome. Let's take this apart again because there's another part inside. What people didn't realize is there's some kind of error with the file, so we've got this crazy thing here. Oh no. I added that when I built this part right there. Duh. There. Oh, cool. So I can delete that box. When I was fixing the star, after I cut out the hole, I left that inside. Just like that. Okay. So now we've got this part. Now I need to take that apart again. There we go. Okay. So now we're back to the original shape that I imported, the original traces, the lines, and we did fill mode default. So I'm going to try this inner line type thing. Ooh, and that makes it way too big. Oh, but the line width is 5 millimeters, so maybe we change the line width to 1.5 millimeters like that. There we go. So that looks a little bit better, right? And how about we do the corners as round? Let's try flat. Let's try sharp. Okay, in any case, I want to do that. Oh, and look at that. We don't even need this circle now anymore. Or this other part. Look at that. That is cool. Okay, so we'll try that print. I'm going to go with that one. And we're going to leave the... Oh, there's a space right there. Look at that. Look at that print. There is a space right there. That might be why we have the problem we're having. It may be lifting up too high. It's trying to print this part as two different pieces. Duh. Because I edited after we did the... oh my gosh. I might just be smart, not smart today. If we drop this down like that, I bet that solves a lot of problems right there. Interesting. We're gonna try that out. We're gonna join that right there. Excellent, excellent, excellent. And you know what we're gonna do? We're gonna check that out in Cura. I think I can share my Cura screen right now. We will share this up. Drop this into Cura. I'm gonna open Cura right now. And I'm gonna open Cura and set it up for my big printer, the printer with this black material in it. I'm going to drop my part in. Cool. Excellent. Okay, so bear with me for just a second, folks. I'm going to open up the view where I can share. Cura. Let's see. Are we there? Yeah, Cura's in the background. Okay, awesome. I see it right there. We're going to share Cura. I'm going to ditch my Chrome view for right now. So this is Cura. This is the slicer for that I use for our 3D printing. And our design team, we have a couple 3D printers here accessible for the team. Yeah, dude, it does look better, right? Now that I'm looking at it, it looks better and it looks aligned. So what I'm going to do is I'm going to check out. We're gonna ignore all that stuff. We're just gonna go to slice, straight up slice right now, and this is just about gonna take an hour and a half to print. If I turn on the feature where we in between every layer take a picture to make a stop lapse video, that time is not included on this. I usually do that with my print server. It's another nerdy stuff that we talked about in a stream in the past, but that adds probably like 50% time to it. So this would take like I don't know, almost 2.5 hours to print with that feature. But then I get this cool like time lapse video of it printing. But we're gonna check this part out right here. This is the important part I want to see. This is every layer, so you can see every layer that's gonna print as we do this, and you can see it doesn't skip a layer in between, so that happens right on the layer. You can see it right there. So I think we've fixed this. We may have corrected the problem, and the problem may not have been anything other than my parts were not aligned in Tinkercad. So let's go back. Let's go back to Tinkercad and check that out. I'm gonna switch views right here. Again, we're gonna go back to Tinkercad. And I'm going to ditch that view so it doesn't get confusing in the background. Let's check out my original. So let's actually drop these right next to each other. We're going to check them out. So there's the original, and there's the improvement. I kind of like the original, but better. It's smoother. But look at the space. There is a space right there where there was nothing holding it together. That's why my print was failing, because the parts were not aligned. That is nuts. So what I'm going to do now is I'm going to take this apart, and I'm going to take it apart again, and we're going to get rid of this part. We're going to lift this part up so that it is on 0. And we're going to lower this part down on it. Like that. Because I am definitely going to print both of these again now. Next to each other. Now that I think my problem is not my print. Okay, let's raise this part 6 millimeters. Just like that. So that's all aligned. Okay, cool. All right. Let's put that all together now. There we go. So now there is no space in between there. That's probably what my problem was. So let's check it out. So we're going to print both of those. And you know what I'm going to do? I'm going to do something crazy on this. I am going to add a bar inside one of these so that we can tell which one is which in case we can't print them together, or in case they look too identical for us. So I'm just going to add the letter L as in Sanskrit to the middle of this one. And I'm going to lower it down so that it is 2.5 millimeters, 2.4 because my layers are 0.2 millimeters. Blah blah blah. It's just better that way for my print height. We're gonna shift this 90 degrees like that. So one of these is gonna have a very thin bar in the middle, so that we can tell them apart in case they show up different, or in case they show up too identical, like that. I am actually going to print both of those probably when this stream is over, but that is amazing that there was a space in there. I'm excited to see that fixed now. So my problem excuse me, as I come back to just chat briefly with me on the stream, my problem was not the grooves, those holes in the bottom. My problem was the parts were spread out. They were not on top of each other. They were not touching. It was not the heat in my apartment, which is creepy that it's a little warm here, but that's, I guess, my little pea brain stuck on that. So the problem was the parts were not aligned properly, and I've experienced that once or twice in Tinkercad. It's a little weird because the alignment buttons don't give you the option to like stack things so that they're touching. That's probably one of the struggles with Tinkercad that I find. So when you stack things, you sometimes have to use the numbers that they're showing you for height and use those as the alignment for you. But yeah, no, I'm definitely going to try this out. In fact, we're going to check out this other part right here, and let's find out if that was also has a space in it. Which, yep, look at that. You can see the space right there in it. We are going to fix that right now also. So let's duplicate this one and drag it way over there. I'm going to print all these together in one batch because I had such a problem when I thought my problem was related to my batch. Let's just line these all up like that. So when I print them, I can print them all in the same line. We're going to take this one apart. We're going to take it apart one more click, and we can see I butchered this piece here. I'm going to grab it. We're going to zoom in. We're going to set it to 0. Oh, my scroll doesn't go up any higher like that. 0. Drag it down to 9. We're going to drag this down, embedded. And we're going to change the height on this to 6 millimeters, like that. Drop that down because that's what I was using to fix the circle that I trimmed out of the middle. And there we go. Cool. So now we've got this part with those grooves cut out of it too. So I'm so psyched. We're going to try all of this in one print tonight, and I think it's going to work out great. Then we're going to mail all this stuff off to our veteran. She's going to have some E8 cookies for her E8 retirement party, and I'm super psyched. This was super fascinating to me because we just problem solved, literally problem solved. Oh, there we go. There's the view. We did problem solve all of this tonight, and that was just so wild to catch. That the tiny little flaw caused me a whole day of printing and wondering, what was wrong with my printer. And it turns out it wasn't my printer, and it wasn't my room. It was that little tiny space. It was 0.22 millimeters. Basically, 0.2 millimeters is one layer of print. If we go back to this Cura and take a peek at this right here, you can see one layer, one of these little red lines like that is 2 millimeters. So we were missing one layer in between all of that. So we printed this layer, and then we skipped this layer, and we tried to print that layer above it, floating, and then we got this nest. So that's what happened to the print, because it was that little tiny 0.2 millimeter gap. And each of these little red lines on this screen is 0.2 millimeters tall. So there was nothing for it to adhere to. That is kind of crazy, right? I think it's kind of crazy. But anyway, let's check this out. Let's get into project number 2. Let me come back and get rid of Kira for a second. Poof. Okay, cool. I think I know why Teams died on us. I think there's a setting in the streaming thing that I should have adjusted before we turned on the stream. Anyway, so let me come back to me for a second. The big screen. Hi, how you doing? So that was our cookie cutter, and that's our thing. This cookie cutter is gonna work out so much better now. It's gonna print with no issues. We're gonna print all 3 of those in the pink line that we just made, and we may even print an extra one of these just because. I'll probably do that tonight while I'm tweaking all the other settings and things, because that's gonna be a long print. I don't know how long it'll run into, like, my bedtime. If that's an issue for me tonight, but that's like the logistics I'll deal with later. But the other thing we've been working on are these trophies and prizes and things for Battle of the Bots, and this is much more fun. I dig this because it's at the beginning stage. It's not at the end stage where we're like problem solving and tweaking all the little things. This is still at like the creative design part, and I'm so fascinated by this part of it because I personally would not have come up with this idea that our design team has dropped into our Slack workspace, and this is the part I dig, and let's just do it. Let's just get into it. So let's go back to Google Photos, and let's get away from this part. Let's switch photos here. Right here, you can see these are light bulb parts to what's going to be a prize or a trophy for Battle of the Bots. And there's a gear in the middle. It's meant to signify the design and the creativity and the ideas and the learning process. I love it. You can see the big one right here was something we printed last week, and this one was something I printed this morning. And there's a difference between the two, so you can see the gear is really well defined on this print. You can see the lines, the threads for the light bulb. I love this. I dig it. And now you can see this one right here. It has some of the same features. I had to do a little tweaking in Tinkercad to get this shape itself out, but there's a feature that is hidden on this, and it's a bottle cap opener. So check it out. So right there is a bottle cap opener, and I have them here in my hand, right here. So let's check it out. I dig this. So this was print number 1 with the gear. You can see the gear. The gear is right there. It's very, very pronounced. I psyched about it. And while we were printing this and while we were doing this, chatting with the design team, I was like, I love this idea that things that represent art could also be functional, and like in a hidden way. Like you look at this and you think, wow, that's a cool concept, but then you don't know that you can take this part off of your prize, and it turns into something like a bottle opener. And our design team made a bottle opener. Check it out. There it is, right there. You can see the shape right in it. So I'm gonna say that when it comes time to print these parts for good, for real, I'm gonna have to add a feature inside of this. And if we go back to the view right here, and I zoom in on this, you can see the little lines right there in the middle. Those lines are not very well held together. This is such a far distance across this that way that some of the lines were sagging. Some of the little strings of filament were sagging in the middle, and I may need to add some kind of like little ring that we break off that will hold these up, because otherwise these are the parts that aren't sticking very well together. And if you come back to my screen right here, I can actually like put my finger on some of the lines and pop them off and make my own little like nest of strings coming off of this. So it's not a flaw with the design. It's just a challenge with the printing, because I printed this with the bottle cap opener on the bottom. So it's like this hole, and it's trying to cover up the hole with the strings, and the strings are sagging in the middle, kind of like I mean, if you tied a rope over a hole, eventually the rope is going to sag a little in the middle, like a telephone lines, or like the sag in the electric lines on your telephone poles and things. That's what's happening here on this for that space. So just a note, as we work on this, as we develop this as a project, I dig this tremendously. But when time comes to actually like say this is a finished model that we're printing all the time, we will probably have to add something in here that breaks away and pops off, so that we can have a nice smooth surface on the inside that isn't gonna pick apart. Like you can kind of hear some of it like coming apart as I scrape my finger across it. But like I said, I love this. The size, we need to scale this. Yeah. I was thinking about flipping it too, because the gear in the middle does the same purpose. So I'm with you. I was considering that we may flip it over and print it that way. It depends on like what features we add into this. Maybe we recess some threads, so that way it's still one part, but the threads look like they're there. But yeah, dude, I'm with you. And like I said, I love this thing to death. The scale, I was so psyched to see that you added. So I ran to the store right before this stream to go grab bottles and cans to test opening, and I mean you can kind of see it needs to be bigger. And this is a problem with designing, not a problem with the design, but a problem with designing in a Tinkercad space or in a CAD space is you don't have a bottle cap. There, I mean, go look at our screen right here. There's why won't you come back? Is my keyboard off? No. Oh, I'm mashing the wrong button. Duh. So, like, look at all these shapes on the side. There's no bottle cap in there. You don't get a bottle cap. It's really hard to make something if you don't have the shape there in front of you. So, what I want to do today to like help my team out is model the bottle cap that I have here. Actually, I want to open this up. I'm going to open this up really quickly. Let me scroll just a second in our Slack workspace so I can find the link. So check it out. So there's the part, and I couldn't print this specific version of it because there's spaces between the part, and you can kind of see that those spaces wouldn't print so well. So I had to take a little bit of it apart to get to the solid object. But there's the bottle cap on the bottom. You can see it. This is like, I love this. I dig it. This is awesome. Like I said, the scale needs to be a little off, but there was something else I noticed when I went to open this, and that is the groove right here on the back that looks like it's meant to be a can opener. So I didn't notice it until I started taking parts apart, and I saw that blade right there. So when I saw this, let me grab it, just that part. When I saw that part right there, I said, oh my gosh, that looks like a can opener. Like you could fit the tab of a can in there. So I went out and got a can and a bottle with the tab so that we could test these out. And I'm this design team, like, I love it. It's very cool to be part of this kind of stuff that happens, and this is my night to contribute as one of the guys and one of the team and one of the gang, and I very much appreciate that. So what I'm going to do tonight is I'm going to recreate the bottle cap and the can tab with my digital caliper, and we're gonna add it inside this Tinkercad workspace so that we can work with it and we can shape the parts that we need, right? Because if you don't have the bottle cap in here, you don't really know what to do with it. So let's do that probably for like the next half hour or so before we call it a night. So I'm gonna turn things around this way. I'm gonna undo everything so that I leave it back the way it was when I found it, because that's just I like to leave things that way. And let's see, let's start with a bottle cap shape, just like that. I'm gonna crank up the not the segments. We're gonna crank up the bevels. Nope, not the bevels. We're gonna crank up the sides and make it round. So here we go. Digital caliper. Bottle of Yuengling. I'm a grown-up. I did not get carded for this. I promise I'm old enough to have this if we're done. But let's see. So what I'm gonna do first is measure the height of this bottle cap. Right there, 6.65 millimeters tall. And I'm going to double check it just to make sure I got it right. 6.5. We're going to go with 6.5 millimeters tall. So that's the size, like the height of our bottle cap. I'm going to come back here. 6.5, like that tall, and I'm gonna keep little screen so you can see me on the little screen, but I'm not really the important part here. So let's check out the top part of the bottle cap, the part where there is no like grooves in it. We're gonna say the top part of the bottle cap is 27. Ooh. We'll go with 27 millimeters round. That is the diameter of this bottle cap. I think most bottle caps are probably the same, so we can go with 27 by 27. Like that. So that is the rough size of our bottle cap. And you can kind of see this fits on top of it, or just inside of it. And that kind of matches, right? That kind of matches like what I just showed you here. So if we come back to me and we say, oh, look, here's the bottle cap, and here's our part. That's pretty close. That's a pretty close representation, right? Cool. All right. Excuse me. So there's this thing we've got. We've got these ripples, these edges. It's the part where the metal is clamped down to kind of create the seal. And yeah, just making sure I'm not missing anything on I'm including the team and things like that, since we're kind of chatting between a bunch of different things. So this part is going to have a different diameter than the top part, which is why I measured the top diameter, and now I'm going to measure the bottom diameter because it doesn't go all the way down. I'm making this wider and wider and wider as I go, and instead of using the points and the edges on this, I'm actually going to use the big chunky surface right here, so that I can get a better representation of the actual size. And I'm going to try to spin this a little bit like that, so I can get the right outer dimension, which looks to be about 28.4 millimeters. So we're going to go 28.4 at the bottom, which now means I can't use 28.4. I cannot use the cylinder anymore. So we need to use this part. So the top radius now, this was 27. So this is 27 diameter. So 13.5 is half. Like that. And let's do base radius of 13.5 also. So now they are the same size. Let's just make sure. Yep, they are basically the same size. Cool. And we said the height of this was 6.5 millimeters. So 6.5, so 6.5 millimeters here. 6.5 millimeters here. And they're the same size. Cool. So we said our the bottom of ours was 28.4. Half of 28.4 is 14.2. So now we've got a slightly wider bottom of the bottle cap. What we don't have are the little tiny teeth and grooves inside of it. But I think what I'm going to do is I'm going to leave this like that. Because I don't see a good option for taking the teeth out of this. And to be honest, I'm not sure we need... So if we duplicate this, let's flip it over so we can see it. Make it 180. So if we were to do something like... I'm going to hold shift down and scale this like that. So now we can kind of see that... Oh, I'm already getting ideas from the team. And I'm with you, dude. I'm in your Tinker space. So if you want to open that link up, you can hop in here and do things with me. But this is the idea is that, oh, I know what you're gonna do. Let's try this again. Ready? Let's pull this over here and take this apart until we get to there. Now we have the hole. And we can grab these. And what I'll do is I will lower this down to 0. Oh, this actually will work out pretty well like that. So we will shrink this just a little bit like that. Let's try that. Let's see how that works. We want it to be pretty close. That's not bad. We'll I think one more scale in. Let's align that way. Ooh, so close. One more. We'll make this 29 by 29. And let's recreate this part. Make it 35. Put this part in the middle. I'm trying to make a cover, like a cutout, like that. Right? So let's see what damage we're doing with this. Ooh, so close. Actually, let's do it. Let's just put it together that way. That is actually pretty close to our bottle cap. Ooh, excuse me. Right there. So you can kind of see it. But that is the shape and the model of our bottle cap now. Some of the pieces are a little off, but that's very close to a actual dimensions of a legit bottle cap right there. And it'll help so much more for designing this. We'll get a better print for this. Make it 30. Oh, make the other part 30. Make this part 30. Well, I made this part 35. You meant the inside here. .30 by 30. We'll align that. No, come back, come back, come back. Join. Make that a hole. Align those two. Oh, we're missing. Oh, maybe. Let's do it. Yeah. Probably would have been better like in between 29 and 30, but that's okay. I mean, we get the idea now. We have the good shape of this whole thing, and I'm going to drop that part on the bottom. There we go. Better view. So we now have a legit shape for a bottle cap, and the bottle cap can fit inside this part here, and we can see whether or not we have the right size as we open this. So now we can see that our light bulb is a little off. It's a little too big. So we might want to do something like this here. Like that. That's probably a more accurate shape to grab those pieces. See, I would print that and I would try this out. But also I would know that the depth is a little off too. We might want to make it taller so that it fits in there. But this is like a super good start. I dig it. In fact, we might even want to make the glow in the dark part a little smaller. But yeah, no, that's a super good start for what we're doing. I'm just gonna set that down into the side right there. So that's our bottle cap. Cool. Back to me for a second. So now we've got this can with the tab, and this is kind of a little more challenging, but I'm going to do what I can to measure this part. So the tab is very thin, very. I don't think I can do this without opening the can, but I'm going to try very, very good. If I open the can, I'll probably have to get rid of it tonight, but excuse me. I think I can measure this without opening the can. It's gonna have to be very, very careful. I'm gonna try something different. I'm gonna use the depth gauge on the bottom of this. Most people probably don't realize this, but there's a depth gauge right there that will tell you the height between here and here, like that. So I'm gonna use the depth gauge to kind of measure the height of this can, the height, how far the tab sticks up off the can. And that's what we're going to go with as far as the dimension is concerned. So here we go. Dropping this down right on there, like that, right in the middle of the loop. You can kind of see it right there. And the measurement is 1.27, about 1.3 millimeters. We can make this larger. We can make this 1.5 millimeters. We could actually go 1.4 or 1.6 millimeters because of the layers. Remember those layers on the printer on the in Cura are every layer is 0.2 millimeters. So this was 0.27. We want to go with either 1.4 or 1.6. We don't want to struggle trying to fit this in there. So actually, this is a representation, so I'm going to go with 1.4 millimeters. So let's grab once again, another round part. And I'm going to crank the sides up. And we're going to, make this 1.4 millimeters tall like that. And now I'm going to measure. Oh, I didn't do the big screen. I'm kind of bad at that sometimes. So I'm going to measure across the can top right there. Oh, nope. Wrong little tab. Right there at the widest. Right there, 16.25 millimeters. 16.25, so we will go with 16.4 wide. 16.4 wide. And it is kind of here's where we're gonna get creative with the shape. So the shape is kind of like this round part right here. And then it's very like long, like a hot dog shape or cigar shape, if you know, like ovals at the ends. So what I'm gonna do is we're gonna make some different shapes here. Let's dive back in here. Let's try this out. So I think we're gonna leave this here at 16.4. And we're gonna leave that as the top like cap. Let's zoom in on that for a minute, so we can get a better view. And we're going to add a 1.4 millimeter tab like that. We're going to make that 16.4 wide. Oh. Nope. Yeah, we should make this 12. Let's try 12 because we want this oval. We want it backwards the other way. Let's go with like a 12. No. Nope, that's not going to work. Undo that. Huh. We need an oval. Let's try this. .4 here. And we'll do 16.4 here. We'll drop this down to there. Something like 7-ish. Now let's just line it upright. Actually, let's use the align tools so I don't mess this up. Oh, and then they're aligned by height. Cool. I'm going to drop this down 1 millimeter like that. And let's take a quick peek at how long the can pop tab thing is, but I don't think that actually applies to opening a can tab. But this is 25.5 millimeters. In fact, I'm going to do it from like straight edge to straight edge and say 16.5 millimeters. So let's make this 16.5 millimeters that way, and we will duplicate this. And I'm going to use something I've never used. I never use ever in like any of my streams or anything else. I'm going to click the flip button, and I'm going to flip it that way. instead of trying to rotate. So this is basically the shape of a tab. And we're going to drag it negative 0.5. There we go. So that is basically the shape of a can tab. There's some other features and things in it, but that's the generic dimension of it. Right there. And if we come back to my view, just here for a quick second, you kind of get the idea that they kind of match. They're similar in size from top to bottom. The can and the cap are similar in size, and you can kind of see that right here if we put them next to each other. They're about the same size. So I think we did good there, and we did a decent job of modeling the basic sizes of those so that we can get a good style print. And then we can test the print. We can actually print them and open these things, and that's what I'm excited for. This is like what I like to do for participating with a team, because we don't always get to do this all together. We're in different time zones and different places with different jobs, different gigs. So yeah. For me to be able to hop in here tonight and to be able to share this with people who might want to do this with us, or even if nobody's paying attention and it's just us on the design team here, it's still super cool for me to participate as part of the design team and to be able to like do this. And I'm glad our design team joined us, even if it didn't work out on Teams. We'll try. We'll try some different stuff for the rest of this month, I think. But yeah, so this is cool. I don't know what that just was, but there was some noises somewhere. Is there a chat? Was that a chat? I don't know what just happened, but there was like a ring, like something happened, like somebody. Oh. Hi, hey, look, there's a viewer. So you're just catching the end, but it was super cool. I will share with you some of the things that we did before we disappear. So here's my sharing screen view. So we were designing this bottle cap opener, and some of these things for our Battle of the Bots design team. We designed some cookie cutters. We actually solved that problem during the first hour of the stream. There was some parts that were not aligned right, and that caused me to spend a day wondering if my printer was broken. It wasn't, and that's about it. You can see that was the mess I was dealing with when the stream started. It's been a super day, but super cool. We solved this problem, and we're printing parts over the weekend. I think cookie cutters will be in our future very, very soon. And I jumped into our Tinkercad workspace to model a bottle cap so that as we work on designing these prizes and trophies and things for our Battle of the Bots competitions, we can make this the right size, because you can see, oh, wrong place. Right here, we got two different sizes for our bottle cap opener. So we went ahead and made a shape that looks like a bottle cap as we joined it. As we set up this workspace to start making a bottle cap opener and a can opener and all those other stuff. So excited to see the rest of this. Oh, don't worry. No, we're technically not engineers. I will say this. I will say that I have a degree in engineering, but I run the Lift and Shift Foundation, and we encourage anybody to join into science and technology. So and not all of us have degrees. Not all of us need degrees. We haven't done anything here today that requires a degree. I don't use my degree too often, to be honest, in doing a lot of this stuff. This is super fun. This is a lot more designing, like graphic design. Actually, when you're making 3D models, I do the engineering stuff more when I'm working with the 3D printers and things. But for the most part, this kind of stuff, it's more like an art. And Tinkercad is free, so I'll end the stream on that note and say, physics is fun and it's cool and stuff. And if you're curious about it, Tinkercad is not our sponsor, but I use Tinkercad because it's a web-based. It's like a web browser. You can go Google Tinkercad. You can go look it up. There's a lot of other stuff you can do in it. You can design 3D models. You can test circuits, like Arduino stuff. You can code with blocks and things in it. There's a lot of cool stuff you can do, and it's a free resource. So yeah, don't stress about not being an engineer and wanting to be a physicist. Those are all cool stuff. I dig it. I love it. I am probably going back to school for my graduate degree soon. So I encourage you to do it. If you want to join the military to pay for it, that's cool too. We most of us were veterans in some way, shape, or form. But this is the end of our project for tonight, and I'm super psyched to see what we do with this as a team, because this is a project that's probably going to go on for a month or two, and I will make sure that on Thursday nights when we hop in here, it's more of us sharing what we do through the rest of the week. Over the weekends, we have a less public Tuesday night that we get together and design some things and talk about our design team as a bunch of designers, not engineers or physicists or anything. But yeah, so this is super cool, and thank you for snooping around. We will see, and to my design team members who are on here also, I will say I think I'll see you Saturday when we're gonna do some more Battle of the Bots build day. I did print our mat, and it's in a 6x8 oval off of a laser printer. So we'll test the line sensors and see how that works, and we'll probably build all the sensors onto our other robot, because I got a bag of sensors Tuesday. So we will set up the dual sensor on our second robot and test the line sensors, and maybe Tuesday maybe Saturday we will get to the point where we run some code and have them duke it out for the first time. But yeah, I'm excited for all of that. Cool. And I have drinks to put back in the fridge, since I've went to the store to go get all these things to model them. But I'm going to hop out of here. Before I go, I'm going to leave with a video. And I'm going to leave with a highlight reel tonight. I'm going to play our 20-minute highlight reel, because most of this is for our outreach program, Battle of the Bots, and people don't get to see it in person because it's only here in New York City. So I'm going to play the highlight reel from that, and that's how we'll end. And we'll be back Saturday building some more of this stuff. See everyone then. Where's my video?